It's from exercise 1.3. Question number 2. Prove that 3 plus 2 root 5 irrational. You are asked to prove that 3 plus 2 root 5 is an irrational number. So it is very simple. Let us take the contrary. So let us take 3 plus 2 root 5 be a rational. We have to prove it is irrational, but we are taking as a rational, and we'll check whether it can be rational or not. We'll follow some steps. So surely it can be expressed in the form of p by q, where p and q as co-prime integer and q must not be equal to 0. So we are taking as a rational, and surely it can be expressed in the form of p by q, since it is taking as a rational. Now you try to separate the root 5. Try to solve for root 5. So let us follow some steps to separate the root 5. First, taking the 3 to the right side, it will be minus 3. And q taking as an LCM. So directly you fill up with p according to the process, and 3 into q, 3q. Here is minus. Now let us separate the root 5. So 2 is taken to the right side as a cross multiply, 2 into q, 2q. Okay, now you observe carefully this value. 2 is integer, minus 3 is integer, q is integer, p is integer, q is integer. So all these are integer. So after calculation you will get an integer by integer. Clearly a rational number. Integer by integer. So it is clearly a rational number. But you know already, we have already proved, or we know already, root 5 cannot get a rational value. So it is a contradiction, because it contradicts that root 5 is an irrational. We know root 5 is an irrational, but it makes false here. It contradicts here. From here, what we got, root 5 is getting as a rational value. Means it is not agreeing that root 5 is irrational. That's why I said it is a contradiction. So it is written here, this by this, p minus 3q by 2q is a rational. So this part, it contradicts the fact that root 5 is irrational. So it is not agreeing. Contradicts means not agreeing. It is not agreeing that root 5 is irrational. That is written here. And this is why it is not agreeing. Why this contradiction? This contradiction is due to our wrong assumption. Our starting is wrong. So wrong things is happen. Our assumption, due to our wrong assumption, our wrong starting, that is 3 plus 2 root 5 is a rational. This is our wrong assumption. This is considering as a rational. This is our wrong assumption. It is wrong. So what should be the correct one? The correct one will be this, just opposite of this. That is 3 plus root 5 should be an irrational. That would be the correct one. And it is due to our wrong assumption. So 3 plus 2 root 5 must be irrational. So it is from exercise 1.3, question number 3. Prove that the following are irrational. So here some real numbers are given here. They are irrational number. You have to prove they are irrational. So I pick up the problem 1, that is 1 by root 2. It is an clearly irrational number. It should be proved as irrational. So for that I'll take the contrary method to prove it. Let us take it as rational. It is irrational, but let me take it as rational. So 1 by root 2 be a rational number. Since it is a rational number, surely it can be expressed in the form of p by q, where p and q are integer and q must not be equal to 0. So surely it can be expressed in the form of p by q, since it is as we are taking as a rational. Then surely by cross multiplication we will get root 2 into p and q into 1 q. And from here you try to separate the root 2. To separate the root 2, keep the root 2 and take this to the right side. Then you will get q by p. Q by p. Root 2 is equal to q by p. Remember, p and q are integer. That is, q and p are integer. So integer by integer, it is clearly a rational value. What we got? Root 2 as rational. But it is not possible. Again I'll repeat, we are getting root 2 is equal to a rational value because it is also an integer by integer. Integer by integer is a rational value. So this part, it contradicts the fact that root 2 is irrational. We know clearly root 2 is irrational, but it is not agreeing here. Root 2 is getting as a rational value, so it contradicts that root 2 is irrational and is due to our wrong assumption. So it is due to our wrong assumption. This contradiction comes due to our wrong assumption. There is 1 by root 2 be a rational. This is our wrong assumption. So it cannot be rational. It would be the opposite one. If it is wrong, then the correct one will be its opposite one. So 1 by root 2 must be irrational. Hence proved. So in the same way you can prove for this also. For this also. Means you just try to separate the root 5 from here. And here you try to separate the root 2. Surely you will find a contradiction and then you conclude it. Thank you.